Hello, everybody. I'm Nimrod. As I was just presented, I'm the co-founder and CTO at Buzz. A little bit about me before we dive into the session about how to build accurate, reliable, and scalable agents. I worked at Bridgecrew, which was acquired by Palo Alto Networks in 2021. We built out a cloud security dev tool. It was based on the open source Chekhov. Has anybody here heard about Chekhov? Yeah, use it? No? Yay, all right, tough crowd. I love building static analysis-based dev tools, and that's what I've been doing for a long time now. And I was an AI skeptic until recently. I think it's important to know our downsides, guys. This is the way forward. What are we going to talk about today? We're going to talk a little bit about Buzz Code Review Agent because it's the context of everything that's going to happen on stage for the next 30 minutes. We're going to see the prototype, how we started out, how things actually were really exciting, but then also came up short, how we benchmarked, how we improved, what we did with prompt, what we did around the prompt, and if you stay until the end, there's a small surprise, so I highly suggest you stay here. So what is Buzz Code Review Agent? Buzz Code Review, in essence, puts comments on your GitHub pull requests, try to extend your architect and help you out with all the problems that are recurring with your pull requests and in your code base. These are just some examples, but what it actually does is it summarizes your pull requests, it does module change graph and understands your code base so it can do better on review and on summary. It aggregates changes by topics. It has reviews according to general best practices, org level. You can even define your own rules. And all of this is also supported via MCP, so you can get your code review within your IDE. There's much more, but thousands of developers are using it. We've got tens of thousands of pull requests every week. So if you want to try us out, we'll talk about this in the end. But in essence, what we are doing is code review. Let's try to build a code review agent together. Okay, we'll build a prototype and then see how it went sideways and how we can build it even better. So step one, we chose GitHub. GitHub is the most popular source code management platform in the world. And we configured a GitHub application to listen to events. You can select whether it's a commit push or a user has to actively request a review for the review to actually run. But let's say we configure the events and we start receiving webhooks. We need to build some kind of aggregator. What the aggregator does is it gets the event that it needs to review, goes and collects the diff, maybe the repository name, pull request title. Maybe it queries the knowledge base for more inputs, and we'll talk about that in the end when we talk about context. But essentially grabs everything, aggregates it, and sends it over to the agent. Every good AI-based tool is just a wrapper for an agent, and the question is how you build out the prompt and the context. So we use Claude Sonnet. It's one of the best models for coding and understands code really well. And we actually ask it to reply with a structured output. That means that when we want to report it back to GitHub, we don't need to do a lot of work, right? The agent already structured it according to what we needed. So when we post it back to GitHub, the aggregator doesn't do much work. That's it. Prototype. Woo! So this 30-minute prototype, we actually put it in, plugged it into our own code base, and we had some amazing moments. Let's look at the first comment right here. The function save embeddings to store is misleading, as the function is not saving embeddings, but rather saving code elements. Now, I'm an AST guy. I've built out AST parsers, Tree-Sitter, if you know. I really understand how code gets connected, but understanding the semantics is the thing that the LLMs do, which no tool has done before. Being able to understand what this function actually does and what the name is and kind of saying this doesn't match was a wow moment for me. The second is another example of understanding semantics. So there's the BFF image tag, which was changed in value between two strings. So AST-wise, it is perfect, but LLMs understand that it's not the same image. So just an FYI. So let's talk about prompt engineering. We have the general template. Let's see how we actually prompt the LLM. So let's say the prompt is simple. Review this code. This is an example comment that we got when you asked to review this code. It says the main point here is this test provides no value. Now, there's a clear comment. I marked it for you. It says this is for dev purposes, so we ignore it on CI. It's very purposeful. If I had to read it, I understand not to delete this test. But when we asked the LLM to review this code, he said, hey, this test doesn't do anything. Let's remove it. So what do? We have to tell it, hey, you need to consider comments when you review this code. Look at the comments, understand if they mean this would be something different, and then behave accordingly. So we're starting to make our prompts more detailed. Let's see another example. We had this comment not long ago where one of our customers used an image with the tag 2025.5.6, and the model has a cutoff date. It doesn't know that this image exists, so it says use the image from 2023. Kind of embarrassing. The solution here is very simple. It's actually an Anthropic best practice. You need to add the date into the prompt, guys. It's very similar in a lot of use cases. It just doesn't know what date is. Cool, so we added another detail to the prompt, and I can go on and on. It's like 20, 30 iterations. Let's stop at 4. It's not aware of future models, so it thinks that future models are bad for you. Okay, so let's say we didn't do 4 iterations like this. We did like 20 iterations, and we are pretty happy about what we see. How do we know how good we are? Yes, the answer is right there. We need to run the agent on a controlled, tested, tagged result list and kind of evaluate where we are and where we want to be. There's a word for it, benchmarking, and I want us to stop on the journey for a little bit and talk about benchmarking. So what is the pros and cons of benchmarking? Everybody talks about benchmarking as being a good thing, and we have to acknowledge that there is a problem with benchmarking. So the good thing is easy. I can deliver with confidence. I made a change. I know it is better. I can deploy it to production. The problem is 2 things that I, as a development manager, hate. First thing, it's pricey. You have to pay for a lot of tokens, and you run it again and again and again until you are sure that it is good. And then the second thing is it takes tens of minutes. Now, I don't know how many developers we have in the crowd, but if I compile for more than a minute, I lose it. So waiting for a test 20, 30 minutes is crazy. Okay? So what do we do? This is my general how-to. You can take a picture of this, I guess. First is make it easy to add a new example to the dataset, guys. The datasets need to be live. They need to grow as you grow and your customer base and your product grows. That is the only way to make sure that over time you remain consistent with your results and your high level of output. The second thing is size matters. When we create a benchmark, it starts with 3 examples, but until it gets to around 20 examples at least, it's not really a benchmark. It's more like a unit test. Okay, you have to have a lot of examples, and for that, yes, make it easy to add a new example. The third thing is deterministically evaluate where possible. We've talked about structured outputs. You can actually ask it to return a Boolean. You can ask it to return the relevant string that you're looking for specifically. Now, when you do that, you're able to actually say, more like a test, is this equal to 2? Yes, no. And when you have structured output, you can actually output a few fields. So one can be a Boolean that you check, and the other can be a string that, I don't know, you can post back to the user. The third thing is some cases you have to evaluate the actual string. That's the hardest cases, and for those we use LLM as a judge. I will say LLJ from now on, and that's for the semantic match. So I have 2 sentences. Are they the same? I don't know. Let's check it out. How do we build it at Buzz? So first of all, we have a directory of JSON and TOML examples. Very easy to add one. Yeah, we log the input if we want to, and then we are able to just copy and paste it into the JSON. Anonymize it, of course, if it's customer data. The second thing is to build the actual benchmark. The actual benchmark automatically picks up all those files. It runs each of them against the model and gets the prediction, or whatever we want to call it. It has to be concurrent, guys. I hate waiting. I think I already said it. I hate waiting. And then the third thing is you have to evaluate each result against the expected via LLJ, a different model than the one that generated your results. Why? Because models like their own results, so they would just say, yeah, it's good. We use 4.0 for the evaluation, while LLM we used in production is Claude, so it's completely different, and we find this to be really good. Now, the LLJ should output a result which is according to these 4 quadrants. It's either a true positive, which means it's something I wanted to see, a true negative, which means it's something I did not want to see and it wasn't presented, or it's something that I didn't expect or that I expected and didn't come. Okay? And the last thing, which is super important for a benchmark, is to define what is the criteria that tells you that you are doing better. The way we implemented it is we have a summary which counts the true positives, true negatives, false positives, etc., and a detailed result, which is basically everything. That way you can easily investigate if something went wrong, but you can have a very easy bottom line to see, am I better? Okay? And this is an actual example of am I better? We use Git for source control, and we commit the summary JSON, so you can actually see where I was before this change and where I am now. And in this example, you can see that in hit rate, we are almost the same. We went down from 46 to 44. But in total comments, we generated half, or almost half, which is a great improvement in noise ratio. And it's, I mean, I appreciate it as someone who uses my product. So, I mean, this is the thing that we check for every change in the prompt. This is the only thing I ask my developers about. Great, so we talked about benchmarking. Let's get back to the journey. So we benchmarked the prototype, and we saw results vary between 12 and 40% acceptance rate. So it's the true positives and true negatives across the entire response. And that's problematic. The problem is consistency. If you've tried to develop with LLMs and ask them something which is not a yes or a no question, I, as a developer, it was the first time for me to feel something that is not deterministic. I run it once, it passes. I run it a second time, it fails. And I really connected with this meme at that moment. So what we did, or what was the problem? The problem is it was a large task. Code review, guys, believe it or not, is a large task. So what we had to do was split it, just like this girl is trying to do something complex, and she's failing at it. And large tasks, if you look at the research, they lead to misses, to hallucinations, and to inconsistency, which is our biggest issue right now. How do we tackle it? We split it across agents. So we run a small part of the problem every time on a different agent, just like these 2 kids riding the bike, and it just works a lot better. I have to say that it's the same for me. If you give me 3 tasks, I will probably fail at all 3. I'm dropping here a diagram from an open source build your own Devin, which is a coding agent, remote coding agent. Feel free to check it out. It's very cool. The idea to see here is the amount of boxes. Okay, this is not a simple, I ask the agent and he's all powerful and all knowing. This is not how LLMs work. So let's update the architecture. Now the aggregator calls a lot of agents. Each agent has a specific task. This does typos, this does logical bugs, whatever, whatever, whatever. And we benchmarked this test. And we saw that we come around 30%. So some comments still seem like a glitch, and our biggest issue was quality. What's missing? Context. And I think this is the limitations of prompt engineering. Okay, you can get only as far as 30, maybe 50 or 60% in good practice. You have to have context to really understand things. So let's look at an example where context was missing. This is a real comment. This migration adds a not null column vendor with default value, but there's no verification that the default value is a valid value. Now, I mean, I look at this comment and I'm like, no, I'm a developer, I wrote it, it probably works, but if you're not sure, you can just check the enum. Right? It's within the code base, you can just check it. Why don't you check it? And the answer is, it's not within the context. Now, context is also important for us people. I'll read this quote out loud. You got the boot from putting boots in the boot. If you've seen Ted Lasso, perfect quote. Context is everything. If you're British, you just got it. Otherwise, you're lost. So how does this translate? When we look at code review, what we need to do is code base-based context. And there are two flavors that we use in Buzz, but the idea here, guys, is this is the secret sauce of your company. Okay, context is hard to replicate. It is built on a lot of data and a lot of knowledge and a lot of hard work. So if this is where you excel, your product will probably be unique in the space that you're working within. We built based on two different setups. One is the vector similarity, and the second is module context. Let's talk a little bit about each one of them. Vector similarity, RAG, or retrieval augmented generation, means that I take all of the inputs that I already have, I hash them, and I save them somewhere. And then I get a new input, I get a question, I get a model that was within the diff. I can take it, embed it, find the closest vectors, and then pull it in. So in simple words, I have a model, which other models seem like it, bring it into the context, and we need to take into account repository, is the same module, package, language, when was it committed? Usually newer code is better maintained and up to standards, and older code is, well, a jungle. And then the last thing is identify patterns that should be used. So you tell the LLM, these are the examples, and you can evaluate this new one against the old ones. So suddenly you get comments that are within the context of what you expect. The second thing is module context. Code is written in directories and files, but when you traverse code, it is more like a tree. You go from one function to a different file in another directory, directly to that function. So it's not really a file-based system, it's a graph. When we look at the elements as developers, we try to find references and definitions. Where is this function used? And that's what we built using AST. So this part is deterministic. It's kind of the graph theory that you see on the wall there. And it's essentially, I have this point which changed, what points are affected or will be affected by it. Great, so we built a ton of context. Let's look at examples. So this is a comment I got, and I'm the CTO of the company. I got this component duplicates the structures both in Jira and Slack integration cards. Consider creating a shared base component. Now I knew we had these integrations, right? I built it, but then I realized that this was an excellent point for a refactor, and I would have never thought about it if the LLM didn't tell me that. Now the wonderful thing about this is that Slack and Jira were not within the context of the diff. I just created a new integration, but it realized that there are other similar integrations, so it leveraged that and actually gave me the entire base component with all the inputs that I can just plug and play into my code base. Now, when I saw this, I had to stop for a minute. I took a glass to drink. I mean, it was too good. This is what I would expect me to comment on my pull request. So when we talk about context, and again, this is a little bit about the platform itself, but we try to think what the user, which in our case is the developer, has in his mind when he writes code. And that's what you should think for your users. How can I get the context that their expert user would have? For us, it would mean the code-based context, so understand all the code pieces that we have, which language, which packages I'm using, stuff like that. There's the ticket context. So I said ticket context, but it's actually all of the things that we talk about in planning and in daily and in the hall. We kind of gather an understanding of what the proposed feature or what the bug should look like. And then we need to take that into the context of the actual fix. For us, it meant mainly the Jira ticket, the linear ticket, Confluence doc, et cetera, et cetera. And then the third thing is the runtime context. A really good developer knows how the deployment of this code will look, and it also knows what it would mean to make this change in the steady state, how it will affect performance, storage, stuff like that. We want to have all of that in the context of the LLM to give a really good review. I'll give you another example with the ticket context. So the ticket title was Improved Performance of Graph Building. We already talked about the graph, right, with the crazy guy. So it gave a whole comment about why you shouldn't break the loop and clear all the cache. I want to focus on the sentence at the end. This could help improve performance. when dealing with our drafts. I mean, the LLM is trying to convince me to implement this, guys. It's beyond the stage of understanding whether this answers my ticket or not. It's actually telling me, if you want to do your ticket really well, you should do this. And this is, of course, a real comment. It's even in GitHub style. So let's benchmark the contextualized review agent, guys. Where are we at? We actually really enjoyed this. And we got to over 60%. Now, this was the moment when we said, all right, we're ready. Let's go all around. And there are lots of other tricks to get this to even higher rates. Okay, so you can go and use all kinds of reflections and flows like the talk before me had, where you have again and again you ask the LLM for different ways to look at it. But I mean, this is just one flow going straight down the LLM path, and we went from 12% to 60%. I will say that we're close to the end. We'll have the surprise soon. But if you want to hear more, we are at booth A55. It's in Hall A. It's the other side of the food court, I guess. That's the name. Cool. We launched the day before yesterday on Tuesday, awesomereviewers.com. Anybody heard about it? You did now. Let me hit the link and I'll show you what it is. So Awesome Reviewers is a collection of reviewers that we built out of open source projects. What we did is we already have internally a process to take all of the comments that other reviewers within the team built and kind of cluster it, analyze it, find patterns, and create reviewers that are similar to those comments. So let's say I'm a Next.js developer. I can filter Next.js right here. And I have the best review guidelines from this repository, guys. Now, I mean, we built a React app. We're not big React developers. So I can just go in and say, how do I optimize Next.js resource utilization? This is based on comments from Next.js. I can just copy the prompt. Well, of course, I should read it, yeah? Don't trust whatever you have. But I can just copy the prompt, put it in my cursor or in my Windsurf, my Cloud Code, and automatically get better code extraction. Of course, if I want to enforce this on the level of pull request because I'm within a team or within an organization, I can use Buzz. I click this link. It will redirect me to Buzz and create a custom reviewer that is based on this. So when we look at the code review in Buzz, it's not just the default, is this secure and does it do what I expect it to? We also look at actually understanding your organization's coding standards, and you can actually even import coding standards from outside if you think they're good enough. Great. Back to this. Let's talk about key takeaways. The first thing you always do with LLMs is you POC. We've had too many times internally where we thought something was great, we built out the pipeline, and then the LLM just couldn't get it right. Okay, so you have to POC. The second thing is benchmarking, and that's just to be able to deliver every time better and better and better. The third thing is prompt engineering is the tool of choice when you need to fix things. It's always fast, you can see the results at the second you made the change, and it's super easy to deploy. It's a string that you modify. It's that easy. But the real gold lies in context, guys. I'm sorry to tell you, prompting, everybody can do. Collecting all the context and building the right input is the hard part. And last but not least, code review is tedious. Let Buzz do it for you. Thank you.